Welcome to practice number 8 of CircuitLab, Motors and Sample Competition. My name is Mr. Burleson, and you can reach me at geaux15@hotmail.com. So, the magnetic field of an electromagnet, or a solenoid, is created by the moving charges in a current going around a loop, or multiple loops. The number of turns over the length or turn density dramatically affects the amount of magnetic flux within the solenoid. You can determine the magnetic field as B is equal to mu times N times I, where I is the current and N is the turn density, and mu is the permeability of the core material. If the core material is air or vacuum, then you can assume the permeability of free space of 4 pi times 10 to the minus 7 Tesla meters divided by amps. So what does the magnetic field look like? It looks something like this. So what you'll notice is that each one of the turns actually creates ripples of magnetic field lines, which when combined create the magnetic field loops. The Lorentz force law combines the Coulomb's law of force and adds the magnetic force. So you can figure out the total force on a charged particle. So if you look at the electric force is equal to Q times E. Or if you want to solve for the electric field of E, you take the force and you divide it by Q. The magnetic force is Q times the velocity cross B. And velocity cross B is where you take the velocity and, using the right-hand rule, multiply it times B. And if they are orthogonal to each other, then it will be equal to V times B in the direction of wherever your thumb would be if you started pointing towards the V and moved it towards the B. The force is actually through your thumb. So electric motors are pieces of equipment that turn electrical current into mechanical force or mechanical work. Okay, so what happens is that the current flowing around the internal solenoids creates a magnetic field, which then makes the stationary magnets push or pull the rotor and makes the rotor spin. And then the more current you provide, the faster the motor spins. The less current you provide, the slower the motor spins. The other thing is that you'll find out that for a DC motor, if I reverse the polarity, I'll actually reverse the current and I'll reverse the direction of the motor. And another thing to keep in mind is that a generator works exactly the same way. It just what you do is you provide the mechanical force to spin the rotor around, which then induces a current. And for a lot of DC motors and AC motors, actually, if you turn the rotor by hand, let's say, or you put it up against a steam turbine or something like that, that's how you generate power. So here's an example of how a motor works. Basically, a DC motor has 2 windings and 2 permanent magnets. The coils are powered from the commutator and the brushes. Okay, so in other words, you're going to have permanent magnets, okay, in there, and then you use the coils, okay, to then create the electromagnet. Okay, so the current that runs through each of the winding changes direction at the halfway point. Okay, and that's caused by the connection of the commutator. okay, such that if you look in the picture below, okay, where you actually have it rotating, you'll notice that what happens is that I have permanent magnets on the outside, okay, and the current is such that in this section, if it's blue, it's actually a south pole. So right now, this, as you see it going through, it's half the time it is pulling itself through, and the other half it is pushing it through. So that's where you get both areas of force indicated. So you'll notice that a proper motor actually changes the direction of the current as it rotates around. So in a brushed DC motor, the motor has this is the one that's got the windings, and what you'll see here is a three winding type motor. The armature is the part that carries the main current for the winding, okay, and that usually consists of a coil with copper wire wound around like an iron or a steel core, and you see that shown above. The part that doesn't move on the outside is called the stator. It's stationary. So you look at the two diagrams to the right, and you can see what's the commutator, and the commutator is the thing that attaches to the brush to allow the current to flow, okay, and then the brush is actually hooked up to wires that would then be hooked up to the battery. Okay, another way of showing it is below, and you'll notice in that case the commutator actually has three parts, and there's always going to be a gap in between the commutator. And then the brushes touch up against that, and then the commutator is the thing that attaches to the windings, okay, and then you're going to have a permanent magnet on the outside. So if you look at this particular case, this shows a commutator on the left and how it interacts with the brushes, and you'll notice that the current flows one way when it's turned a certain way, and then it flows a different way when it goes the other way. And so that's how you get the back and forth turning of a motor. And then when you see it, then the armature attached to a motor on the right hand side, you can see the permanent magnets, the stator on the outside with the windings in between, and the armature is spinning around as part of the rotor assembly, and then you've got the commutator in the middle there, and then attached to that are the brushes. So that's called a brushed DC motor, okay? Now these brushes are normally made out of carbon, okay? And they allow the current to continue even as the rotor rotates. So the small gap, if you will, lets you switch from one set of windings to the next, calling the switch polarities, okay? So remember, the commutator rotates with the rest of the rotor, whereas the brushes do not rotate. So now brush motors are going to be your most common, but keep in mind the brushes eventually wear out, okay? And especially if it gets too hot, it's run too fast or something like that. Non-brush motors use the magnets on the rotor and then pulse the current on the windings on the stator, okay? And that motor, you know, the brush motor, it moves as fast as the current it has, whereas a non-brush motor is all about the pulses. Now, what are some problems? Brushes are going to wear out. Also, you'll notice that every time you get ready to switch, okay, because you're not moving those magnets, you will actually have higher torque at different parts of the rotation. Okay, and it actually even goes all the way to 0, and then it pops back up. Now, for most of the time, this is not a big deal, but sometimes you want to have more constant torque. And so that's when they'll do stuff like you'll see below where they'll have the triple windings, and then that sort of fills in the gaps, if you will. Remember, keep working on your binder. It is your partner, and it allows you to have an open book test. Always use your binder whenever studying, practicing, and keep adding to it throughout your entire season. Now, let's talk about in a competition. They're normally going to be about 100 points, okay? They're usually, I would recommend when you first start doing your practices, you only give yourself 40 minutes. Generally speaking, the shortest time you'll ever be given during an actual competition is about 45 minutes. But if you practice giving yourself only 40 minutes or 30 minutes, you'll get so used to working at speed that when you get 50 minutes, it'll be like having extra time. Okay. Now, make sure that you do your written quizzes both individually and as a team. Individually, so you know where your weak spots are, and as a team, because you know where your team's weak spots are. Use all the notes that are in your binder. Use your calculator, okay? Always practice filling out your name and team at the top of each page. And the reason why is if they separate the test, you want to make sure you get points for everything. Always tackle the easy problems first, and then the tough ones you know how to tackle. And then finally the ones you're guessing on. That will improve your luck. The other thing is make sure that you get the easy problems and the tough ones that you know how to tackle. Make sure you get those right. You're much more likely to get those right than you are the really, really hard ones. And if you have time, check your answers. That's also a great thing that your partner can do. So for homework, I'd like you to update your binder to get it competition ready. And I want you to complete the circuit problems from level 1, level 4, level 1 magnetism, level 4 through 6 combination circuits.